Hello guys, I'm Sasinsi. For those watching for the first time, like, comment and subscribe. Today we want to find the inverse of a 3 by 3 matrix using the Cayley Hamilton Theorem. Now to find the inverse, we should find the characteristic polynomial of A in terms of lambda, which is P of lambda is equal to the determinant of A minus lambda times the identity matrix. This will give us the characteristic polynomial. Our A is 4, 2, minus 2, minus 5, 3, 2, minus 2, 4, 1. We subtract identity matrix times lambda. Let's solve it here. We have lambda times the identity matrix, which is 1, 0, 0, 1, 0, 0, 0, 1. It will be equal to lambda 0, 0, 0, lambda 0, 0, 0, lambda. So lambda times identity matrix will be lambda 0, 0, 0, lambda 0, 0, 0, lambda. When you subtract this, it will be equal to 4 minus lambda, which is 4 minus lambda. 2 minus 0 is 2. Then minus 2 minus 0 is minus 2. Minus 5 minus 0 is minus 5. 3 minus lambda. Minus 2 minus 0, which is 2. Minus 2 minus 0 is minus 2. 4 minus 0 is 4. And we have 1 minus lambda. Next step is to find the determinant. Since we have this is now our A minus lambda times the identity matrix. Now we want to find the determinant of A minus lambda times the identity matrix. It is always plus, minus, plus. So to find the determinant, we have 4 minus lambda into, we cross the row and the column and we pick 3 minus lambda, 4, 2, 1 minus lambda. 3 minus lambda, 4, 2, 1 minus lambda. Then we have minus 2 into, we cross the row and the column, we pick minus 5, minus 2, 2, 1 minus lambda. Then we have plus minus 2, which is still minus 2, into, we cross the row and the column, we pick minus 2, minus 5, minus 2, 3 minus lambda, 4. Now, we want to find the determinant. Let's solve this step by step. Let's start with the first part, where we have 4. Let's solve it this side. We have 4 minus lambda into 3 minus lambda 2, and we have 4, 1 minus lambda. To find the determinant, we have 3 minus lambda times 1 minus lambda minus 4 times 4. So let's solve the inner part. We'll multiply the part later. We have 3 minus lambda times 1 minus lambda minus 4 times 2, which is 8. When we factor these, we'll have 3 into 1 minus lambda minus 1 into 1 minus lambda minus 8. 3 by 1 is 3. 3 by negative lambda is minus 3 lambda. Then we have negative lambda times 1 is minus lambda. Negative lambda times minus lambda is plus lambda squared minus 8. The highest power is lambda squared. Minus 3 minus 1 is minus 4 lambda. Then 3 minus 8 is minus 5. Then we multiply this by 4 minus lambda, which is 4 into lambda squared minus 4 lambda minus 5. Then we have minus 1 lambda into lambda squared minus 4 lambda minus 5. To factor this, we have 4 lambda squared minus 16 lambda minus 20. Here we have minus lambda cubed plus 4 lambda squared plus 5 lambda. The highest power is minus lambda power 3. Then we have 4 lambda squared plus 4 lambda squared is plus 8 lambda squared. Then we have minus 16 plus 5, which is minus 11 lambda. Then we have minus 20. So this is the solution to the first part. First part, we have minus lambda power 3 plus 8 lambda squared minus 11 lambda minus 20. Let's now solve the second part. We have minus 2 into minus 5, 2 minus 2, 1 minus lambda. To find the determinant, we have negative 5 times 1 minus lambda minus negative 2 times 2. Let's solve the inner part. We'll multiply the outer part later. The inner part, we have minus 5 into 1 minus lambda, then minus negative 2 times 2, which is now plus 4. When you open the bracket, you have minus 5 plus 5 lambda plus 4. Negative 5 plus 4 is minus 1 plus 5 lambda. And remember, all of these we multiply with negative 2. So that will be negative 2 times 1 is 2. Negative 2 times positive 5 lambda is minus 10 lambda. So we have plus the second part, which is plus 2 minus 10 lambda. Let's solve the last part. Minus 2 into negative 5, 3 minus lambda, negative 2, 4. Let's start with the inner part. We have minus 5 times 4 minus negative 2 times 3 minus lambda. So we have minus 5 times 4. Minus 5 times 4 is minus 20. So minus 20 minus, in bracket, minus 2 times 3 minus lambda. We have minus 20 minus, this will be minus 6, this will be plus 2 lambda. When we open the bracket with a negative, we have minus 20, it will be now plus 6 minus 2 lambda. Minus 20 plus 6 is minus 14 minus 2 lambda. And remember, all of these we multiply with negative 2. Negative 2 times 14 is minus, it will be now negative times negative is positive, so it will be 28. Minus 2 times minus 2 lambda is now plus 4 lambda. So the last part we have plus 28 plus 4 lambda. Let's cancel the common. Let's start with the highest power. The highest power is minus lambda power 3 followed by plus 8 lambda squared. Then we have minus 11 minus 11 minus 10 plus 4, which will be minus 17 lambda. Then we have 2 plus, we have minus 20 plus 2 plus 28, which will be plus 10. Let's multiply all across by negative. We'll have lambda power 3 minus 8 lambda squared. We'll have plus 17 lambda minus 10. Now, this is now our characteristic polynomial. Now, the next step, substitute lambda with a to verify the Cayley theorem. So, we have, it will be lambda, it will be a cubed minus 8a squared plus 17a minus 10 times the identity matrix. By Cayley Hamilton theorem, we find that when you substitute lambda with a, it will be equal to 0. When you solve this, we will get 0. By so doing, we find that a power 3 minus a squared plus 17a, we cross 10 to the other side, we'll have plus 10 times the identity matrix. 10 times the identity matrix is just 10. We factor out a since it is common on the left. So we have a into a squared minus 8a plus 17 times identity matrix. We want it to be in form of a 3 by 3 matrix. So it will be 17 times identity matrix and is equal to 10. Let's multiply both sides by a inverse. This one cancels. On the left we have a squared minus 8a plus 17 times identity matrix, which is equal to 10 a inverse. Let's divide both sides by 10. On this side will remain with a inverse is equal to 1 over 10 into a squared minus 8a plus 17 times identity matrix. So this will be our inverse. We need to find our a squared. A multiplied by itself, we have 4, 2, negative 2, negative 5, 3, 2, negative 2, 4, 1, multiplied by itself, which is 4, 2, negative 2, negative 5, 3, 2, negative 2, 4, 1. Up to this point, we know how to multiply a 3 by 3 matrix. We multiply row with the column. So we have 4 times 4 plus 2 times minus 5 plus negative 2 times negative 2. When we work out all that, we'll have a squared equal to 10, 6 minus 6, negative 39, 7, 18, negative 30, 12, 13. When we solve a squared, we'll have 10, 6, negative 39, 7, 18, minus 30, 12, 13. Now we substitute. We have a inverse is equal to 1 over 10 into our a squared is now 10, 6 minus 6, negative 39, 7, 18, negative 30, 12, 13, minus 8 times a. Let us solve 8 times a. We We have 8 into a. Let us solve it. Then we equate it back to our equation. We have 8 times a, which is 8 into matrix A, which is 4, 2, minus 2, negative 5, 3, 2, negative 2, 4, 1. 8 times 4 is 32. 8 times 2 is 16. 8 times minus 2 is minus 16. 8 times minus 5 is minus 40. 8 times 3 is 24. 8 times 2 is 16. 8 times minus 2 is minus 16. 8 times 4 is 32. And 8 times 1 is 8. So 8 times A is now 32. 16 minus 16 minus 40, 24, 16 minus 16, 32, 8. Then plus 17 times identity matrix. 17 times identity matrix over 3 by 3, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. 17 times 1 is 17, 17 times 0 is 0, 0, 17 times 0 is 0, 17 times 1, 17, 17 times 0 is 0, 17 times 0, 0, 0, 17. Now you have plus 17, 0, 0, 0, 17, 0, 0, 0, 17. Now here we have A inverse is now equal to 1 over 10 into, we have 10 minus 32 plus 17. 10 minus 32 plus 17, which will give us negative 1. We'll have negative 5. Then we have 6 minus 16, which is minus 10 plus 0. We have 6 minus 16, which is 10. 10 plus 0 is 10. We have minus 6 minus 16, which is minus 6 plus 16 plus 0. It will be minus 10. When we solve all those, we'll have minus 5 minus 10, 10. Here should be minus 10, 10. And we'll have 1, 0, 2. Then we'll have minus 14, minus 20, 22. Then we multiply across by 1 over 10. A inverse is now equal to 1 over 10 times minus 5, which is minus half. 1 over 10 times minus 10, minus 1. 1 over 10 times 10 is 1. Then we have 1 over 10 times 1 is 1 over 10. 1 over 10 times 0 is 0. 1 over 10 times 2 is 1 over 5. 1 over 10 times minus 14 is minus 7 over 5. 1 over 10 times minus 20 is minus 2. And 1 over 10 times 22 is 11 over 5. So our A inverse using the Cayley Hamilton theorem is now negative half, negative 1, 1, 1 over 10, 0, 1 over 5, negative 7 over 5, minus 2, 11 over 5. Thank you for watching. Subscribe. like and comment.